All right, so before I explain or solve the simultaneous equation, just to show you something quickly. So if we have a matrix A, and let's say the matrix has the components 2, 1, 3, and 4, and you want to find A inverse, what do? To find A inverse, you put 1 over the determinant of A. All right, this symbol means determinant of A, two straight poles like, and then multiply by what you call A adjoint, or the adjoint of matrix A. All right, so in order for us to find the inverse of A, we have to put 1 over multiplying these two, so it could be 2 times 4, minus multiplying these two, so it's 1 times 3. All right, so this part down here is called determinant of A. So that's what we just worked out here a while ago. 2 times 4 minus what? 1 times 3. So we just write that down there. And then we're going to multiply that now by what we call a 2 by 2 matrix, which is the A adjoint matrix. It's a 2 by 2 matrix. A adjoint, you find that by doing this. Let me just explain that quickly. You're gonna switch these guys. Switch 4 and 2. So we're gonna put 4 here and 2 here. And then we're gonna you're gonna multiply this guy here by -1. And you're gonna multiply this guy here by -1 as well. So when you multiply 1 times -1, you get -1. When you multiply 3 by -1, you're gonna get -3. So when you simplify this, all right, you're gonna get 2 4s 8, and 8 minus 3, that's 5. And you have 4, -1, -3, and 2. Now where the 1 comes from? This 1 over, let's go back down here quickly. Yeah. Where the 1 comes from? This 1 divided by, that we have here, 1 divided by. That's just part of the formula for finding A inverse. Just part of the formula. So it's a little formula that we use. All right, so what we need to understand is that this number down here is what we refer to as a determinant. And this matrix that we have here, this one here, is what we call the adjoint matrix. When you form them together like this, 1 over the determinant times the adjoint, you call that the inverse. Now, here's the thing though, here's the deal. You see, whenever you multiply a matrix by its inverse, so let's say we're gonna take now matrix A and multiply by its inverse. A multiplied by its inverse, or its inverse times A. These two will result in the same thing, the identity matrix, which looks like this. 1 in the leading diagonal and 0 in the non-leading diagonal. This is called the identity matrix. So just for proof, I'm going to show you quickly that when we have 2, 1, 3, 4, right? I'm going to multiply by A inverse. In fact, let's put A inverse first because it's easier to work it that way. All right, so we're going to put A inverse first. 1 over 5 times 4, -1, -3, and 2. All of this is A inverse. Now we're going to multiply it by matrix A. 2, 1, 3, and 4. Now what we're going to end up with the identity matrix as we said. So you're going to see that's the case. All right, so we're going to put 1 over 5. Let's keep that out there and then multiply these guys here. So we're going to say row by column. So now 2 will multiply negative, 4 multiply 2, and -1 will multiply 3. First by first, multiplying, right? And second by second, again, we're multiplying. And then we're going to add the two answers. So it's going to be 4 times 2, which is going to give us 8, plus -1 times 3, that's going to give us -3. All right, so let's do the same thing with the same row, because we have another column. So we're going to take the same row and multiply the next column. So what's it going to be? It's going to be 4 times 1 plus -1 times 4. And so 4 times 1 is 4, plus the -1 times 4 is -4. Okay, all right. Now, I can just put this down for the time being. I'm going to put back the 1 over 5. I'm going to write back this matrix here, the resultant matrix I have here from multiplying these two matrices. 8 minus 3, because plus negative is a minus, right? So I'm saying 8 minus 3, which is 5. 8 plus negative 3, this becomes minus. I say 8 minus 3 is 5. Okay, good. And 4 minus 4, that's 0. So far we can see what's happening, right? It's going to look like this, as I said. But we have to multiply by the 1/5. We multiply each entry, each result by 1/5. So basically, this will help us when we're trying to understand why we just go straight from A to A times A inverse to the identity matrix without showing the multiplication on the left-hand side. That's exactly what I'm doing here. All right, to avoid the confusion. So we're going to do the same thing here. Let's see. Let's go down now to row 2, because we finished multiplying by row 1. So let's go down to row 2 now. So it's row 2 times column 1. So we're going to go first by first, second by second. So negative 3 times 2, that's negative 6. Plus 2 times 3, that's 6. Now negative 6 plus 6, that's going to give us 0. Put it in the calculator. Negative 6 plus 6, you're going to get 0. I can put all of these in your calculator, by the way. You can get these entries. Now, we finished multiplying by what? We finished multiplying row 2 by column 1. So we need to now multiply row 2 by the next column over here. Column 2. This will be negative 3 times 1 added to 2 times 4. So negative 3 times 1 is negative 3. Sorry about this ugly looking 3 here. But negative 3 times 1 is negative 3. And 2 times 4, that's 8. And of course, negative 3 plus 8 is the same thing as positive 8 minus 3. Alright, so 8 minus 3 is 5. Okay, good. And then we need to simplify this now. So we're going to say 1/5 of 5. 1/5 times 5. 1/5 times 0. 1/5 times 0. Okay, good. Now when we simplify this, 1/5 of 5 is the same thing as what? Let's 1/5 times 5. That will give us 1. So we know that this is going to work out. This is going to work out to what? 1. So 1/5 of 5 is 1. What's 1/5 of 0? Anything times 0 will be what? 0. Could have just simply said 1/5 of 0. Put the answer there. Now 1/5 of 0, or again, same thing, is going to be 0. Now we have 1/5 of 5 again, as we had before, which is 1. So do you realize that's a concept that we need to understand? That anytime we multiply a matrix by its inverse, we're going to get the identity matrix. So this was matrix A times its inverse. Here we have its inverse of A, which is 1 over the determinant times the adjoint. That's the inverse of A, multiplied by A. The order doesn't matter when you multiply the matrix A by its inverse. A times inverse or inverse times A. We're still going to end up with what? The identity matrix. Alright, so there's another second part that you need to understand as well. So now you understand that A times inverse give you the identity matrix. What about the identity matrix? When you multiply the identity matrix by another matrix, what do you end up with? Alright, what do you end up with? But let's try that. Let's see what happens when we multiply the identity matrix 1, 0, 0, 1 by another matrix. Let's say 5, 4. So we're going to multiply row by column. So this is another principle you need to understand. So it's going to be 1 times 5 plus 0 times 4. So 1 times 5 will give us 5. Added to 0 times 4 is 0. So we finished multiplying the row by column. There's no more columns. We're going to go down to the next row now. Alright, so the next row now, row by column. So we're going to say first by first, added to second by second. First by first, so that's 0 times 5, which is 0. Plus 1 times 4 is 4. Now 5 plus 0 is 5, and 0 plus 4 is 4. Do you realize what we end up with? When we multiply the identity matrix by another matrix, we end up with the same matrix. This is the matrix we multiply by the identity matrix here with. We got about the same thing. So the identity matrix behaves like 1. So it's just the same thing as saying what? If we remove the identity matrix and put the number 1 here, we'd have still gotten the same result. 1 times 5 is 5, 1 times 4 is 4. So the identity matrix, right? The identity matrix behaves just like the number 1. So that's two principles. A times is inverse. So let's close with this. A inverse times A gives us the identity matrix, which is actually 1, 0, 0, 1. And if we multiply the identity matrix by any other matrix, let's say B, we end up with B. And if we say matrix X, as in the variable matrix, as we were doing with the simultaneous equation, end up with the matrix X. Because this I, the identity matrix, operates like the number 1. So let's go to the question that we have. Let's go to the question. This is the original question that we had, right? And we're going to see how we can use that principle that we learned a while ago, or the principles we learned a while ago, to solve this. So here we have the two equations, and we want to format them into the matrix equations, ax equal b. So all we need to do is to take the coefficients, -3, -2, and we just have a negative in front of x, but we know it's really -1. We have a plus in front of y, so we know it's +1. So -3, -2, -1, and +1. Those are the numbers that are multiplying to the left of the variables. And x is the variable matrix. Just put x, y there, because x and y are the only two variables we have. And at the end, equal, we have the constant matrix 0. We're going to have 0 and -5 within the pair brackets. That's going to give us the constant matrix. Now, to find the determinant of matrix A, we know matrix A is the matrix with components as we have them here. To find the determinant, we know what to do, right? The determinant of matrix A is a number which is equal to what? This times this, which is -3 times 1 is -3, minus the -2 times -1, which is going to be +2. And -3 minus 2 is -5. So that is our determinant. Next, we want to find the adjoint of matrix A. So again, let's write what matrix A is. And then we can now write A adjoint afterwards. Alright, so matrix A is the matrix with the components -3, -2, -1, 1. So A adjoint, what do we do with A adjoint? See these two guys, what are we going to do with them? We're going to switch them. So 1 should be here and -3 to be here. And what about those entries? Those entries in the non-leading diagonal. I mean here and here. Here are the non-leading diagonal. Leading diagonal entries, non-leading diagonal entries. What are we going to do with them? Are we going to switch them? Of course not. We're not going to switch them. But instead we're going to multiply them by what? We're going to multiply them by -1. We'll multiply this as well by -1. And while we do that, what happens? We're going to get +2 and +1. So this is what we refer to as A adjoint. Switching and changing the sign. Change the sign, we just say negating. We're negating. What's A inverse? A inverse is a combination of 1 divided by the determinant of A times A adjoint. Now we have those two information already, right? So we can say A inverse is equal to 1 divided by, what's the determinant of A? We found out how to be -5. Yeah, determinant of A is -5. So we put -5 below here. 1 divided by determinant of A. And the adjoint is a matrix, so we're going to just simply put times the adjoint. But we don't need to put times. Once we have a bracket, we have a quantity outside, we're multiplying. So we're going to put the 1, the 2, the 1, and -3. That's A adjoint times the 1 over determinant. Okay. So now what we're told here is to use the inverse to solve for x and y. Now this is the original matrix that we wrote in the beginning. The what? The matrix equation. And so what we're going to do is to multiply that equation that we have here by the inverse that we have formed. Again, the inverse is formed by what? 1 over the determinant times the adjoint. So what we do, we're going to put 1 over the determinant and multiply by the adjoint. Let's give some more space. So it's 1 over the determinant, which is 1 over what? -5. Right? Times the adjoint. Remember, these things go together to become what? The inverse of A. So that's A inverse literally. Now we're going to multiply by A, which is right here. -3, -2, -1, and 1. That's A. And we're going to write now the variable matrix times a constant. No, we're multiplying both sides by the inverse of A, right? It's the inverse of A. So on this side as well, we need to write that as well. The first thing we need to put is the inverse of A. Don't make the mistake of putting the constant matrix first. That order matters in this case. All right. Okay. Now why order matters is because if you put the 2 by 1 matrix first and the 2 by 2 matrix after, remember these numbers will not match, you know. So that means you can't multiply them when you're that direction with that order. So you have to put the 2 by 2 first, then the 2 by 1, and then these inner numbers will match so that we know that we can multiply them. Alright, so if you understand what I'm talking about, that's good. If not, just simply put the inverse, A inverse first. So this is A inverse multiplying by the constant matrix. So the A inverse is multiplied on both sides. Alright, so let's look at the result that we're going to have. Alright, so what we learned earlier is that a matrix multiplied by its inverse will give us the identity matrix, which is a 2 by 1 matrix with the components 1, 0, 0, 1. So this is A inverse multiplying by A here, above here, right? So when you multiply those two, you're expected to get what? The identity matrix. So we don't need to show the calculation. In your solution, you don't need to show that. This A inverse times A will combine to give you what? They'll combine to give you what? The identity matrix when you multiply them. Right? Multiply A inverse by A. You expect to get the identity matrix. So I'm going to just replace these two guys with the identity matrix. The 1 over -5 is part of the inverse of A when you put those two together. Remember that. So it's 1, 0, 0, 1. That's the identity matrix that has been produced. And what we have here is the variable matrix, components x, y. Alright, so this is the part that we need to work out now. Okay, because we don't have any principle over here to give us any type of particular type of matrix. But what we have is a fraction, right? 1 over -5 times a 2 by 2 matrix times a 2 by 1 matrix. So what we're going to do, we're going to multiply the 2 matrices first. So when you're working out this side, multiply the 2 matrices first. This matrix by this matrix. Okay? So let's do that. So what we're not using is the fractions. We want to put that back. Let's work out this now. Working out this, you know how to multiply 2 matrices, right? How do you work them out? You multiply a row by column. And so we're going to have 1 times 0 plus -5 times 2, or 2 times -5. Let's go. So it's 1 times 0 plus 2 times -5. Remember, row by column gives you one answer, one entry. So all of this will give us one answer. 1 row times 1 column give us one answer. So we should put a plus sign. When you multiply first by first, put a plus sign, second times second. Alright, that's when you're multiplying. Now we're finished multiplying that first row by first column. Because we only have 1 column, we now have to move on to the next row. There's no more column to multiply by, so we drop down to the second row. Multiply by that same first column. 1 times 0 added to -3 times -5. Now 1 times 0 is what? 0. Let's put it in. 1 times 0 plus -3 times -5. Alright? And of course, when you simplify that, what are you going to get? 1 over -5. Let's simplify what we have in bracket. This is going to give us 0 here. 1 times 0 is 0. And 2 times negative 5 is negative 10. 1 times 0 is 0 here, so we're ignoring that. Negative 3 times negative 5, that's positive 15. Right? This will cancel out. And 2 times negative 5 is negative 10. Negative 3 times negative 5, that's positive 15, because negative times negative is positive. 3, 5, 15. This is 0, so 0 plus 15 is 15. And so let's work on this side though. We want to do this both sides simultaneously at the same time, in other words. Remember what we said about identity matrix? The identity matrix acts like 1, remember that? So if I say the identity matrix times b, we get back b. The identity matrix times x, we do get back what? X, right? Recall that? And I showed you how as well. All right, so what we're doing here, we're not going to do any long calculation. But if you want to, we can, we can say this times this. But to me, that's just wasting time. All right, and if you do it, you will see that it's actually going to give you back the same what? It's going to give you back x and y there. The 2 by 1 matrix with x and y as components. Because 1 times x is x. That's why we have x here. And 0 times y is 0. So that's x plus 0 is still x. Go down to this row, 0 times x is 0. And then 1 times y is y. So that's 0 plus y, give you y. Okay, hope that was clear. Then write back this. And then we're gonna find 1/5. We're gonna find 1 over negative 5 to be more clear. Doesn't matter where the negative goes, at the side, at the top, or below. Still negative 1/5. Multiply by negative 10, the first component. Now the negative times negative is positive. And we can say 1 times 10 is 10, and 5 times 1 is 5, and 5 goes into 10 twice. So combining this scalar or fraction by the first component by way of multiplication, they combine to 2. So we should not see this fraction anymore after we multiply by each entry. Okay, because they combine together. These two combine in multiplication to form one new number. Now negative 1/5 again times 15. The same number multiplies the other number now. Negative times positive is negative. 1 times 15 is 15. And 5 times 1 is 5. Alright, so we're still going to have negative there, because if you think of this as a positive, negative divided by positive is negative, and 5 goes in 15 3 times. In other words, you're going to have 3. So that's going to be negative 3. So those are answers. Now, basically, you realize when you have two matrices being equal, it's a 2 by 1 matrix, 2 rows, 1 column, 2 rows, 1 column, and they're equal. It means the corresponding entries are equal. So this entry here corresponds to this entry here. So we can take them out the bracket by saying x is the value or the number 2. And then we can also say now, since we took the x out, we can say y corresponds to negative 3. So outside of the bracket, we can just simply write that y is the number negative 3. So those are two answers. X equals 2, y equals negative 3. So if we check it out, x equals 2, y equals negative 3. When you put it inside of this, we should get 0. Let's see. This is saying negative 3 times x, minus 2 times the value of y. X is 2, y is negative 3. Will we get 0? Well, this will give us negative 6. Negative 3 times 2 is negative 6. Try a calculator. And negative 2 times negative 3, that's positive. Negative is positive, 2, 3, 6. And of course, these are opposite signs, so we subtract 6 from 6, give us 0. Hence, we have the 0 here. And also, if we say negative x plus y, let's substitute negative times the x value, which is 2, plus the y value, which is negative 3. Well, that's negative 2 plus negative 3. This will actually work out to be a negative. So it's saying negative 2, and you can think of it as minus now, if we're reading it. Negative 2 minus 3, that's going to give us what? Negative 5. That's our solution right there.